Hi everyone. In this video, we're going to start by introducing the integers. So today we're going to begin working with sign numbers, including our negative numbers now. So let's go through a bunch of definitions first and talk about the different terms we're going to see, and then also really just what integers are. So far we've only dealt with really the whole numbers. So those are all positive numbers. And now we're going to start bringing in those negative numbers. And to do that, I want to start by looking at a number line. So a number line looks like this. I have an arrow on each side because it does continue in both directions. And typically you have 0 in the middle. And then you have the numbers 1, 2, 3, 4, and so on, continue on the right. And again, that arrow means it's going to keep going forever. So I could keep counting up and up and up. And then on your left, we're going to introduce the negative numbers now. So we're going to count out really sort of the same way, 1, 2, 3, 4, etc., but with negative numbers instead. So in the middle, obviously you have 0. And then what you're going to see is you're going to have your positive numbers on the right. And then on the left of 0, you're going to now have your negative numbers. Now, I know we really haven't gotten to fractions and decimals quite yet, although we've talked about a little bit here or there. You actually do have all your fractions and decimals in between. So for instance, the value of 1/2 would be right here, halfway between 0 and 1, or the value of 2.5 would be right here between 2 and 3. Same thing on the negatives. If I had negative 1/2, it would be between 0 and -1, or negative 2.5 would be between -2 and -3. So you do have all the values in between as well, but we're just going to focus really on those whole number values plus their opposites, so those on the negative side here too. Now, together, we call the positive numbers negative numbers, and 0 the sign numbers. So sometimes you'll just hear us refer to as the signed numbers, and these could be positives or negatives. It doesn't happen to be one sign or the other. We do include 0 in there too, although 0 is neither positive nor negative. So I will make a little note here that 0 is not positive and not negative. So it lies in between the positives and negatives here. Another thing I do want to note here with your positive numbers is we typically do not put a sign in front. So you will notice with your negative numbers, you do have a sign in front. You have that negative sign. For your positive numbers, we don't typically put anything in. You technically could. So sometimes you'll see things written like +3 for +3, or maybe +2 for +2. But like I noted, again, we don't typically write the sign in, so you'll just see it as 3 or 2. And if there's no sign, you should note that it is a positive number in that case. Now, sign numbers also include all the numbers in between as well. So when we get to fractions and decimals next week or the week after, then we will also incorporate those with positive and negative. So your sign numbers do include the fractions, the decimals, all that stuff as well here. So specifically your integers is the set of numbers, and this is going to continue in both directions. that is basically just the whole numbers and their opposites. So your integers do not have fractions or decimals included here. And as I said, we're definitely going to get to fractions and decimals later on. We're just not here yet. So our integers are the whole numbers, but also including the negative parts as well there. Now, there are lots of applications of sign numbers. So for instance, I could say that the temperature, or that let's say the wind chill is 10 degrees below 0. And assuming we're in Fahrenheit here, we could express that value then as negative 10 degrees Fahrenheit. Or I could say something like the temperature is 97 degrees Fahrenheit. It is very hot, right? So here, in this case, we have 97 degrees. This is a positive number. Again, because there's no sign in front, so we assume it's positive, whereas here we have a negative. Another common example could be something like the boat sunk to 100 feet below sea level. So if we're below sea level, we're under the, or in the ocean, right? We're underneath. That is often referred to as a negative number. So this would be negative 100. And you can see that word below does often refer to some sort of negative. So if it's below 0 for temperature or below sea level, then we're talking about a negative value there. So there are a lot of applications here for positives and negatives, and these are just a couple of them. Maybe one last example, I won't write it down, could be with money, right? So let's say we are going to the bank and we're going to pay some bills or something like that. So I'm going to take money out of my bank account to pay some bills. Let's say I take $100 out. Then my bank account would be changing by negative 100, right? We're removing $100. So you have like a negative 100 idea there. Or let's say I just got paid and I'm putting my paycheck into my account, then my bank account is going up in money. So I have a positive value. Maybe I got paid $500. So I have positive $500 going into my account. So again, negatives and positives have a lot of applications here, not with just temperature or with sea level, but also even with money, right? Making deposits, so adding money to your account would have a positive change to the balance, whereas if you took money out of your account, you'd have a negative change to the balance. That would be decreasing. So I want to keep working with that number line a little bit more, and I want to do some examples about graphing integers. So graphing just allows us to have a visual, and we're going to be doing a lot of graphing throughout this course. So now we're just kind of starting with the basics. Our number lines are really just one dimension, right? We're just kind of doing one number line here, and eventually we'll get to our two number lines looking at full graphing at the end of our course. So graphing is just a way to visualize. So let's look at an example. Let's say I want to graph the following: -6, 5, 0, 1 and -4 on a number line. See if I can focus this a little bit here. Sorry guys, let me try to focus this again. Oh, this is killing me today. Hang on. All right, now it's all fixed. Let's keep going. So the first thing I'm going to do is obviously I'm going to draw that number line. Now, you don't have to put 0 in the middle, right? If I had a lot of positive numbers, I could put 0 more on the left, so I have more room for my positives. If I have a lot of negatives, I could put 0 closer on the right, so I have more room for my negatives. So usually we just put on 0 there just so we could have a few numbers on each side and see some positives, some negatives, but it really doesn't matter where you put it because that number line does go on forever. So I can really make it as long as I want to. I do have positives and negatives on both sides. So I'm going to just put 0 right around the middle here. And I just want to make sure I go out to at least 6s, right? I'm at -6 here on the left. So let's see, positives go on the right. And then negatives go on the left. And again, notice that you're counting out. So we start with the 1s first, then the 2s, then the 3s, and so on. So you want to just keep in mind you have your positives here on the right. And we have our negatives on the left. So let's go ahead and graph some of these values. So I'm going to start with -6 first. So if I look at -6, I can see that negatives are on the left. It's way over here. And what you do is you just fill in a solid dot right on that -6. For 5, that's a +5. So I'm looking over here on my positive sides. I see 5, and I just fill in a circle or a dot all colored in on that 5. Now 0 is right in the middle in this case, so I'm just going to put a point right on that 0. I have +1, which is right here. And then I also finally have -4. So to graph something or to plot points, so these are really all points. We're just putting that closed circle, that closed dot on our number line. So that's really all we have to do for graphing. And the number line is really nice too, because it also allows us to compare integers. So let's go through a couple just definitions here for a second. So just to recall that this symbol here is the greater than symbol. And this symbol here is greater than or equal to. And the other direction, this is your less than symbol. And this is your less than or equal to symbol. And all of these things together are called inequality symbols. Now, what you're going to notice is that when using a number line, numbers to the right on a number line are greater or bigger than numbers on the left, and numbers on the left of a number line are less than or smaller than a number on the right. Now, an easy way that I remember this is I think left means less. So if a number is on the left, it is less. So we can use our number line up top here and just do a few examples. So let's say I wanted to compare -6 and -4. So those are 2 points that I already have. If I look at -6 and -4, I see -6 is on the left and -4 is on the right. So what happens is that numbers to the right are bigger and numbers on the left are smaller. So -6 is smaller than -4. So -6 is less than -4. Let's compare 0 and 1. So here I have 0 and 1. Again, 0 is on the left and 1 is on the right. So 0 is smaller and 1 is bigger. So 0 is less than 1. Let's compare 5 and -4. So here I have 5. Here I have -4 on the other side. -4 is on the left, 5 is on the right, so 5 is bigger, right? -4 is smaller, so 5 is greater than -4. Okay. The other thing you may want to notice, is a good little trick for inequality signs, is do notice that the small pointy end goes with the small number. So that small little pointy end is always pointing towards the smaller number. So if you're kind of getting stuck on which is which, again, hopefully you can read through here and remember your less than and your greater than directions. But if you're having trouble, that small pointy end goes with the small number. So it points towards the smaller number. So here it points towards the -6, points towards the 0, points towards the -4. Okay, so you always point toward the smaller number. And again, don't forget that little symbol also means number, not just hashtag. All right, a few more definitions. So this first section is very definition heavy. There's a couple like little topics we have to go through. So the next thing I want to talk about is an absolute value. So you have a definition here. So the absolute value of a number is the number's distance from 0. And the symbol that you use here to represent an absolute value are 2 vertical lines like this. So you want to be careful because if you're reading particularly on a computer screen, it can be a little tricky. So absolute values have vertical lines, so it's different than parentheses or brackets. I know they all kind of look similar. So for instance, let's say I want to find, let's use a different color, the absolute value of 5. Well, what I can do here is I could draw my number line first. So here's 0, 1, 2, 3, 4, 5. Let's put a few values in on the other side. And we're going to the distance from 0. So basically you're saying, okay, here I am at +5, and here is 0. What's my distance? Well, I would count 1, 2, 3, 4, 5 spots. So the absolute value of 5 is just 5. All right, let's try another example. Let's do the absolute value of -4. So I'm just making my number line. And again, I'm just adjusting 0 right or left a little bit so I have more room on one end. So here I am at -4. And the definition is that is the distance to 0. So if I count up, I go 1, 2, 3, 4 units to get to 0. Now, I encourage you to try a few more examples here, and hopefully you will see the pattern. And what you want to notice is that your distance is always positive. So distance is not negative. Distance is always a positive idea. Okay. So your shortcut for the absolute value is to just take the positive version. So for instance, the absolute value of 6 stays 6. The absolute value of -7 stays or becomes +7. The absolute value of 100 is 100. The absolute value, I'm going to bring in a decimal here, -1/2 is +1/2. So even with decimals or fractions, it's going to be the same definition. I just want to make that clear. So the absolute value of -2.5 would be +2.5. So my answer is always positive. The only exception is if you have the absolute value of 0. So the absolute value of 0 is just 0. And remember that 0 is not positive or negative. So you're just going to leave 0 as is. But otherwise, you're always just taking the positive version instead. So that's the shortcut. It really is a distance to 0, but we can use that shortcut here to help us get our answers a little bit quicker. All right, I want to do a couple more examples here, a little bit maybe more complicated. So what if we look instead of something like the absolute value or negative absolute value of -5? So now I have a negative on the outside and a negative on the inside. What you want to do in a case like this is do the absolute value part first. So the absolute value of -5 is just going to be +5. This becomes 5 here. So my answer then, this negative is going to stay here. And then this 5 just tacks on here. So my answer is actually -5 in this case. The negative on the outside just tags along here. And then this answer does end up becoming positive. So my final result is negative, but the absolute value part is still positive. Let's do one more like this. What about negative absolute value of 8? So again, that negative is on the outside. It's not on the inside. So I'm going to do the absolute value first. The absolute value of 8 stays 8. And then this negative is on the outside. So what happens is it's just going to tack along. So if you have these more complicated absolute value problems, you can still do it. You just want to take your time with it and simplify that first. Okay. I'm going to actually do one more example here. Let's say I had something like the absolute value of 4 minus 3. Now, an absolute value symbol also is a grouping symbol. So you would use your order of operations here. Do the 4 minus 3 first. And 4 minus 3 is 1. So this becomes the absolute value of 1, which is just 1. Okay, so if you have something more complicated on the inside, you don't want to take the absolute value of each number. So you don't want to do 4 plus 3 is 7. You want to simplify inside first, just like a regular parenthesis or a bracket with order of operations there. And one last set of definitions here, and I've mentioned this word already, but I didn't define it, and that's the word opposite. So two numbers that are the same distance from 0 on the number line, but are on opposite sides of 0 are called opposites. So for example, okay, 4 and -4 are opposites. Or -5 and 5 are opposites. And again, I know we're doing integers right now and really focusing on whole numbers, but this definition also works for fractions and decimals. So just to throw one in there, 1/2 and -1/2 are opposites. Okay, and so on. So this definition does apply to fractions and decimals as well. Now, one thing to note here is that another word or another phrase is additive inverse. So inverses in math are opposites. There's all different kinds of opposites, right? So the opposite of multiplication is division. The opposite of addition is subtraction. Here, these are opposites because they are the same distance from 0, but have different signs, right? One's positive, one's negative. So in math, there are a lot of different kinds of opposites. So another way for this specific style to say opposite is additive inverse. So that's the more formal way. So if you're reading a text or you're looking online and you see the term, what is the additive inverse of 4? The answer is -4. Or what is the additive inverse of -5? The answer is just 5. So that's just a more formal way to say opposite. Okay, so let's do another example. So find the opposite of each number. So let's say I give you the number 3. Well, the opposite would just be -3. Or if I gave you -2, the opposite would be +2. If I gave you 0, I mean, the opposite of 0 is actually just 0 because there's no sign there. It doesn't switch signs. So you could leave it as 0. And also more formally, sometimes we will write this. If A is a number, then negative A becomes A. So what's happening here is you have two negatives. So this really says the opposite of -A or the opposite of the opposite of A. Okay, so that negative sign, you can sort of think of as the word or the phrase opposite of. Okay? So they sort of cancel each other out. If you take the opposite of the opposite, then you're right back to where you started. It's kind of cyclical like that. So when you have a negative and a negative right next to each other, what we're getting back out is the positive version. So we're saying the opposite of negative A would be positive A. So just something that's good to know there as well. So for instance, full examples here, if I have negative 4 and then I put another negative on the outside, then my answer is just 4. If I have negative and then negative 10, my answer is just 10. Or if I have negative and negative 500, my answer is just 500. Now you do want to be careful. These are parentheses here. This is not absolute value. So we just did an example like this. So be careful. If I have negative absolute value of negative 500, that is different, right? So now I have an absolute value symbol. That part becomes 500. So then my overall answer is negative 500. So we've seen this a couple minutes ago. So just be careful. This rule is true for parentheses. It's not true for absolute values. So that's if you have parentheses or brackets. Brackets would be okay here too. So that would be okay, but not absolute values. So you just want to be, again, really careful there as you're going through. Actually, let's do one more example here. Okay, so let's evaluate negative, absolute value of negative x if x equals negative 4. Now we're making this a little bit harder here. So thinking back to evaluating expressions, so what we're going to do is we're going to take that x and we're going to replace it with this negative here. So what you may want to do is just write everything. It helps to use some different colors, and when I replace it, I do like to use parentheses. So I'm going to take that x and replace it with negative 4, and I just use parentheses to help remind me on how to deal with this. So what we have here, and I know I'm kind of running out of room of paper, but we have an absolute value symbol, so I have to work inside that first. And I do have parentheses here, so these two negatives really look like this part right here, right on the inside. So the inside of the absolute value is actually going to become just 4. And then the absolute value of 4 is 4. So my answer is negative 4 here. So we do this next. So with these more complicated problems, you just really want to take your time. Don't rush them. Really use different colors. Use parentheses when you evaluate and plug things in as well. Hey everybody, so I just want to talk about one last thing with introducing positive and negatives here, and that's that we can also have bar charts that do have negative values as well. So here's an example, and again, I just found this online just to show you guys from the tablebar.blogspot.com. And again, I don't think it's real data or anything like that, but I just thought it was an interesting example to show you how you could have positive and negative values here. So in this chart, what we're looking at is that the temperature, and obviously these are very extreme swings, right? So I don't think this is real data or anything like that. But the temperatures for Monday, Wednesday, Friday, and Sunday are all positive. We look at the height of those bars, you know, Monday is almost 40 degrees, Wednesday looks like it's around 70, Friday is positive 80, and then Sunday is at around 50 degrees. So those are all positive values. When you have the bars that go underneath like this, for here it's the pink colors, Tuesday, Thursday, and Saturday, these represent negative values. So our temperature on Tuesday was almost negative 80 degrees. The temperature on Thursday was about maybe negative 64, I'm estimating degrees. And then Saturday looks like it was maybe around negative 56 degrees. So just want to show you an example where you could have bars going above and below the axis, although it's probably not as common as our regular bar graphs. But we could ask questions here as well and say something like, well, what is the hottest day? So our hottest day refers to the highest temperature. That would be positive. So in this case, Friday would be the hottest day, right? It has the highest or the tallest bar graph going in the positive direction. I could also ask a question like, what was the coldest day? Well, The coldest temperature would be the lowest temperature. And remember, for negatives, that means the more negative you're going, right? So you're going further down that number line. So in this case, Tuesday is the lowest bar here. It has the lowest temperature at almost negative 80 degrees. So again, you just want to remember that for negatives, you're moving left on that number line to get lower, right? So even though the number looks like it's getting bigger, right? You think you're comparing 80 to 60, for instance, because it's negative, negative 80 is a smaller number than negative 60, which is smaller than negative, 50. So our coldest temperature here would be on Tuesday, which is almost negative 80 degrees.